to do all the proofs in one video, so if just proofs are what you need help on, then you can just do this video. So I'm going to draw a picture and start off with the given. All the givens should go just in a box. A is between M and P. Points M, A, and P are collinear, which means they make a straight line. And then the information to help me solve, MP is 24, MA is 4x minus 2, AP equals x plus 1. All that is given information. So all that I can put in my picture. Okay, so you start to look at this picture. If this was just a regular problem, we'd say, how do we solve it? We would use segment addition to solve for x, and then plug it back in to prove what MA equals. So step 2, I'm going to write segment addition. Technically called the segment addition postulate. So you don't have to memorize that word, just know that you're doing segment addition here. So like MA plus AP should equal the whole length of MP. Okay, now we substitute in our numbers. That's called substitution. So I'm just going to abbreviate property. Okay, I like to combine my like terms first, so I'll add my x's together and get 5x minus 1 equals 24. We call that combining like terms, or some people call it simplify. We're simplifying that side of the problem. Either way you want to write that, both are acceptable. Then to solve, I would add 1 to the other side. When you go across the equal sign, we'll call that addition property of equality. Okay, POE for property of equality, because that addition went across an equal sign. And then I would do division here, and divide, I get x equals 5. So that's division. Property of equality. Okay, and we still have to substitute this back in because we want to find MA. So step 7, I'm going to say MA equals, and I'm going to plug in 5. So 4 times 5 minus 2. That would be called substitution. And then question 8, if you simplify that, 20 minus 2 gives me 18, and that is what we were trying to prove. So I did simplifying there. I had 4 times 5 minus 2, I simplified that to just the number 18. So key things to make sure in your proofs, whatever is given needs to go at the top of your proof, and whatever you are trying to prove needs to go at the bottom of your proof. Okay? So given always goes at the top, what you're trying to prove always goes at the bottom. Alright, let's look at the next one. This is our angle relationship with parallel lines. We'll start off with, they told us that line AB is parallel to line CD. We want to prove 4 and 7 are supplementary. Now right now, if you look at 4 and 7, they don't have any kind of relationship. So we have to kind of go about this a roundabout way. I would probably do, you just need it's like a two-step problem. You need to do 2 steps in order to show that they are supplementary. So I could do, one way I could say 4 and 5 are supplementary. Angle 4 and angle 5 are supplementary. And I know that because 4 and 5 are called consecutive interior angles. And then I also know, so how does 5 relate to 7? Because we want a 7 here. So I can say angle 5 is congruent to angle 7. Or you can put equals if you want to put equals, because those are called vertical angles. Now I'm going to say angle 4 and angle 7 are supplementary, which is what I was trying to prove. I just kind of had to go a roundabout way to get there. So, because 5 equals 7, I can replace the 5 with a 7. We call that substitution. Substitution property. So, lots of choices. Maybe you want to say 4 and 3 are a linear pair. Are supplementary because they're a linear pair, and then you say maybe 3 equals 7 because they're corresponding. You need some relationship that shows they're supplementary and some relationship that shows something equal, and then you can substitute that into the other problem. So again, lots and lots of choices on that one, but we just need 2 relationships there to prove that one. Okay, now we're going to do a parallel line problem. Only this one has algebra in it. So we'll start off with our given. AB is parallel to line CD. The measure of angle 2 equals 8x plus 2. The measure of angle 8 equals 10x minus 8. That's all my given. So angle 2 here and angle 8 is here. So I would say angle 2 should equal angle 8. And I would call that alternate exterior angles. That is a relationship between those 2 things. Okay, so now I'm going to substitute in the numbers they gave me. You need to show the relationship before you start plugging in numbers. And now you can choose which way you want to solve. If I look at what I'm trying to prove, it has the x on the left-hand side, so I'm going to subtract my x's to the left. I know from in class, a lot of people like to take their letters whichever way makes it positive. You can choose either method. So I'm going to choose to subtract 2, and I could have done that in one step now that I look at it, because both of these lines are subtraction the way I did it. So I could have just wrote it once and subtracted both of those at the same time. And your last step here to get x by itself would be division. You would divide the negative 2 to the other side. That's called division property. Okay, and if you look up at the top, I wanted to prove x equals 5, and at the end of my proof, I have x equals 5, so I know I did it correctly. Alright, the next one I'm going to give you a picture on. It did not have a picture with it, so let's draw a picture here. obviously, on all proofs, we start with our given, so I'll write down that ray DF bisects angle CDG, and ray DG bisects angle FDE. Alright, so what does bisects mean? The key word here is bisects. Bisects means it's going to cut something in half to make two congruent angles. So let's see what angles would be congruent then. DF bisects CDG. So that makes this angle equal to that angle. Then it also says we're going to have another set of angles that are equal because we also have another bisector. This one, DG, is bisecting FDE. So this angle is equal to this angle. And both of those are called definition of angle bisector. Bisecting an angle, and you saw the word bisect, so in our problem here we need the word bisects. So if you look at this, we have one step left. Angle CDF is congruent now to angle GDE. If you look, we had CDF equaled FDG, and FDG equals GDE. So if you eliminate the middle things, because those are equal, these two should be equal. We call that the transitive property. And that is our proof. So you can expect to have something on parallel lines. You can expect to have maybe an algebra question. You can expect to have a segment question, whether it's midpoint or segment addition. You could have an angle bisector one. This is one that commonly comes up on the test, so you make sure you pay attention to that when you are studying.